This is part 4 of section 1.2, use segments and congruence. Last video we looked at segment addition postulate, that was postulate 2, where you can add 2 little segment lengths to get a big segment length. And when they give you the big segment length, you can take that and subtract a little segment length to get the other little segment length. New stuff for this time be a new definition. We're going to use this word a ton, probably at least 1,000,000 times this year. Segments with the same length, those are called congruent segments. And notice the little symbol that comes after that word congruent there in green. It looks like an equal sign with a little squiggly thing above it. That's called a tilde. When you put those two things together, that's a congruent sign. So when you see that, you read it as congruent to. Some people think it looks like a toothbrush with some toothpaste on it. Let's look at our number line at the bottom here. This number line has a bunch of segments on it, bunch of points that are named, bunch of points that aren't named, and there's some coordinates down there. Again, you can pause this video and you can fill in those missing coordinates if you like. They're telling us from A to C is 2 units, and I totally agree with that. H to J is also 2 units. We're going from the first coordinate to the third coordinate. That's a difference of 2. So those have lengths of 2. When you have segments with equal lengths, you can call them congruent. So what we would say there is that the segments themselves, notice how we have the segment mark above the letters now? Those segments are congruent. If you back up for a second, the lengths equal a number. So notice how there's no segment mark there? That's because we're talking about a length. The lengths are numbers. The segments are congruent. Same thing if you move to the right there. From B to G is 5. From I to N is 5. Again, you can find these lengths by counting, or you can subtract the coordinates. If those 2 segment lengths are equal, what do you know about the segments? They're congruent. And this is how you show it down there. Segment BG is congruent to segment IN. So again, this slide just kind of points out what I tried to emphasize on that last slide. The lengths are equal. So when we don't have the segment marks above, we're talking about lengths. When you don't have those segment marks, you have to put an equal sign. When you do have the segment marks on that shorthand notation, and we're talking about segments, and they have the same length, those segments are congruent. Notice the difference. When the segments are there, you got to put the little squiggly there for the congruent sign. When they're not there, you don't put the squiggly sign there. That means they're equal to. Okay, another thing to point out, we have a horizontal segment and a vertical segment over on the side. Segment AB is horizontal, segment CD is vertical. Notice how they have matching hash marks on them. See the black mark in the middle there? If you see matching marks on segments, what that means is it's telling you that those segments are congruent. So maybe we don't know their lengths necessarily, but the marks are indicating that they are congruent. You're going to see that a ton this year. Okay, last example for this video, we have a number line. And again, you can pause the video and fill in the coordinates. I think this might be the same as the last example, though. Let's go back and look. Sure does look like it. Okay, so true or false, are the segments congruent? Don't just put true or false. We need to actually give a reason why. So for example, segment BF, is it congruent to segment HL? You can pause this, count those lengths, and then compare them. Segment BF has a length of 4. Segment HL has a length of 4. You should write that down. B to F equals 4. H to L equals 4. Since they have the same length, it's true. They're congruent. Next one down, segment AD has a length of 3. Segment EG has a length of 2. Write those lengths down. They're not equal, so the segments are not congruent. You would put false for that one. Segment IL has a length of 3. Segment JN has a length of 4. Make sure you write those down. They're not equal, so they're not congruent. Segment AE has a length of 4. Segment GL has a length of 5. They're not equal, so they're not congruent. Next one, a little bit tricky. Is segment OP congruent to segment OP? Well, I don't see a point O or a point P there, so how am I going to find the length of segment OP? I'm not. But what if I compared a segment with itself? Would it be congruent to itself? The answer to that is yes. That's true. That's called the reflexive property. Again, you can write that in there. We're going to talk about the reflexive property a lot this year. Last one. If segment QR is congruent to segment ST, then is segment ST congruent to segment QR? Well, again, we don't know their lengths, so we can't really compare them. But aren't they the same segments? They are. So they are going to be congruent. You're comparing a segment with another segment and then saying that that other segment was congruent to that first one. So you have two different segments. They're congruent either way you write them. That's true. That's called the symmetric property. And again, we're going to use that a lot this year in class.